These two examples, we're going to continue with our u substitution, but we're going to be doing definite integrals versus indefinite integrals. So our definite integrals are we're going to be finding these areas under these curves, but it has very much a chain rule kind of a look to it. And so we can use u substitution to undo that. So there is another thing, though, that will potentially make this a little bit nicer for us, is that when we do our u substitution, we're going to change, and you don't have to do this, but you can. And some people will find this easier, and some people aren't going to love this, and that's okay. So you can change your bounds, which is the 0 and the 1, with u substitution. All right, so what that means is once I go into u substitution and I start doing this process of replacing my x's with u, I don't have to go back to x's as long as I change my bounds. If I want to leave my bounds, then just like we do with anything else, go back, sub back in your, get rid of your u, put your x's back in, and then finish finding the area under the curve. But there's potentially a little bit of a shortcut to it. So first thing I want to recognize is that this is my inside piece. If I do the derivative of x squared, I'll get an x. I'll in fact get 2x. And so my u right now, the way it sits is going to be 4 minus x squared, right? So I will be rewriting this in my du. Let me kind of work through this a little bit. Is negative 2x dx. I have, when I rewrite this, 4 minus x squared, I have a 2x dx perfectly lined up, so I don't need to get rid of everything, but I do need to bring the negative sign over. 2x dx. Okay. So when I'm starting to rewrite this, I have a negative sign. My 2x dx is going to be du, and then this is just going to be u. So u du. So here's where you can decide if you don't want to come back to the original, if you're going to have to, if you're subbing out u, you can sub out your bounds as well. So to do that, it's as simple as I'm going to plug 0 in. So I'm going to be doing, plugging 0 into this. So it's 4 minus 0 squared, which is 4. And then I would be plugging 1 in and go 4 minus 1 squared, which is 3. So as soon as I do that, I do not have to come back to x squares. I can finish off everything. I can plug things in terms of u, and I'll get the exact same area under the curve. If I didn't do this, I did my u substitution, I pulled this piece back in, and then I subbed in, you're going to get the exact same thing. Now, the one little hiccup that I have going on in mine is this is the kind of the wrong order. I want to go small to big on this. So if I do that, it switches the sign. So my negative will become positive if I switch my signs or if I switch my bounds. Right. And again, you don't have to do this, but a lot of times it does make it a little bit less math as we kind of go through this, but it will get you the exact same answer. All right. So if I do this and I leave my bounds, I'm going to put everything in terms of u. I'm going to do adding my power, dividing my power. And I'm going to go from 3 to 4. So I have a 1/2. That's going to be times 4 squared minus 1/2 times 3 squared. So since this is just going to stay as 9/2, I might as well just leave this as 16/2. So 16/2 minus 9/2 is going to be 7/2. And you would find that if you went back and put this back in and you had your 4 minus x squared and you were plugging in a 0 and you're plugging in the 1, you end up getting a 4 and you end up, like it all will work out, no problem. So it's up to you. If you want to sub it out, sub it out. Every once in a while I don't. Most of the time I do. Just kind of a personal preference. So let me do the same type of thing on this one. This is definitely a u substitution where this is my inside, this is my outside. My derivative of x squared can give me an x. In fact, give me a 2x. That's fantastic. So my u value is the x squared plus 1. My du is 2x dx. So let me rewrite this from 0 to 2. Let's make it so it's antiderivative friendly. Let's pull that up. So it's x squared plus 1 squared. And I'm going to pull the 2x to mix it with the dx. Those line up perfectly, so that's du. And this is going to be u squared. And since I'm in terms of u, I might as well keep going. I just got to figure out what my new bounds are going to be. So if I plug a 0 into this, that's going to turn into 1. If I plug a 2 into this, that's 4, 5. So I'm really going to bound, my bounds are going to be 1 to 5 if I leave everything in terms of u. And then I'll add my power, divide by my power. So u cubed divided by 3 from 1 to 5. So that's going to become 5, so 1/3 of 5 to the third minus 1/3 of 1 to the third. All right, so here I'm going to have 125, 125 over. Sorry, I checked something over. I missed one tiny little detail, which is screwing everything else up. I brought this up. This should be a -2, which makes this a -2. When I add a power, I'm getting 3 divided by 3. I'm getting a -1 dividing by a -1. Sorry about that. Let's clean this up here a little bit. So this is really going to become a negative 1 over u is really what we're going to be plugging our values into. Um, so that's going to get us a -1/5 minus a -1 over 1. All right. And then I'll clean this all up. This is -1/5 plus, might as well make a 5/5 out of that, which gives us a 4/5 as our answer. All right. Sorry about that. I don't know how I missed my -2, but I did. So something felt wrong along the way. So negative power, we add our power, divide by our power, and then we end up getting 4/5. And again, for me, I didn't want to go back. Once I started doing my u substitution, I might as well just keep everything in terms of u. I just have to make sure that I change my bounds appropriately then.